So James is up next, and he's going to talk about, or he's going to write DNS messages for us. Those of us who don't know, DNS is a sort of protocol we use for finding out names on the internet.
So I'm talking about handwriting DNS messages. I was messing around with sending web requests, and I realized that every time your browser sends a web request, it needs to do a DNS lookup first. A DNS lookup basically maps the human-readable domain name, like example.com, to a machine-readable IP address. I had no idea how this actually worked, so I wanted to write a DNS resolver. It turns out writing a DNS resolver is really easy as long as you know how to encode and decode DNS messages. So like 80 or 90% of that project was like encoding and decoding DNS messages. So today I will show you how to do that. It is a lot of like binary writing. So my slides are very visual because that's the only way to like portray that in some like reasonable way. So yeah. So DNS messages all have a common format. So the request and the response messages both have the same format. And this looks like this. Because requests and responses both have the same formats, we only need to use a subset of this format for the request. So we only care about these two sections. The first thing we can look at is the header, which looks like this. And again, because request and response use the same thing, we only care about the things I've left in bold. The first of these is an ID, which is just a 16-bit number that is used to identify the message. When we send a query, the server will respond with the same ID, and we can use that to match up the query and the response. For ours, let's just go with, for the things we don't care about, we just zero out. For the ID, we can go with 8 ones and 8 zeros arbitrarily. QR is a flag that specifies whether this is a query or a response. Ours is a query, so we'll set it to 0. Opcode is the type of query. We're doing a standard query, so that's also 0. TC is whether the message is truncated. Our question is small, so it won't be truncated, so that's 0. And RD stands for recursion desired. If you send a query to a DNS server and they don't know the corresponding IP address, it can recursively ask other DNS servers. We do want our DNS server to do this, so we set that to 1. The second column here is known as the query flags, and 0100 is like a super common format for this. QD count is the number of questions we'll be asking, which is 1. In hex, it looks like this, so it's like super simple. We have our ID 0100 and then 1 question. Cool. The next thing we care about is the question. And that has this format. So we'll look at, so QName is where we have like put the domain name we want to look up, and we'll like look at that last because it's a bit more complicated. QType is the type of record we're looking for. We want an A record, so that's just 1. QClass, this is like an internet DNS lookup, so that's also 1. For the QName, to write this, you write out your domain name, and then underneath you write out the ASCII codes for each of those, and you prefix each of those with the length. You terminate it with a 0 byte, like in C, and then that's the whole QName. So if we stick all of those together and convert them to hex, it looks like this. So we have the header and we have the question. We just stick those together and send it to a DNS server, and that's it. This is like our whole message. I think it's like 27 bytes. So yeah, super simple. To send the message, we have a little Python script. Can you see my cursor? Yeah. So here is the message written out in hex. We are sending this request to 8.8.8.8, which is Google's DNS server. And we're sending it to port 53, which is the standard port for DNS requests. Here we initialize a new socket, and we're using sock dgram, which is a UDP. DNS is usually sent over UDP. We convert the message to binary and send it to the server and wait for a response. And then we convert the response back to hex and print it out. If we look at the response that we get, it looks like this. I've split it up into sections. The header is almost identical. The only difference is in the flags. So previously this was 0010 and now it's 8180. That's just because, like, you know, instead of query response set to 0, it's set to 1, things like that. We have one question and we have one answer. The question section is identical to before, and this is our answer section. So to decode the answer, it has this format. And the only thing we care about here is the R data section. The R data section comes out as these 4 hex bytes. And if we convert that to like decimal integers, it gives us our IP address. So that is how you handwrite a DNS message. I think, like, this is way lower level than you'll probably ever need to go. Like, I don't expect any of you to use this. I think the reason I want to give this talk and the reason I think this is useful is because, like, I'd like to encourage you to, like, go deeper and try and understand how things work on a deeper level. I had never written binary before, and I was really intimidated by it, and I thought it'd be terrifying, and it turned out to not be, and it was, like, fairly straightforward. If you want to read more about this, I actually originally wrote this as a blog post, so if you go onto my website at routley.io, you can see that. RFC 1035 is the original RFC for DNS, and it's where I got all the cool, like, ASCII diagrams from. And that's my Twitter and GitHub if you want to say hello. Cool, I'm done.